Welcome back everyone to the Hello World Guide. This is another episode of the C++ Raycaster game series, and in this video we are going to continue by adding some optimizations to our floor rendering code that we created in the last video. So you can see that I have opened up my renderer file here, and inside of this I'm going to go down here, and here we were drawing our floor, and you can see that we have got an SFML vertex array here for our floor pixels, which is basically means that we are using points to draw this. And if I run make right now, you can see that it's giving around 35 34 frames per second on my computer, which is not that bad, but it might run slower on some hardware, and it's generally not that good of a performance. So we could optimize it quite a bit. So for that we are going to go ahead and replace this vertex array. We are not going to have a vertex array here anymore. Instead we are going to use a standard arrays, and we are going to basically then use that to draw an image and onto our screen, and we are going to fill the pixels ourselves. So I'm going to change this from an SF vertex array to an array of bytes, basically unsigned bytes, so unit 8. So we are going to make it an array of that, and the size of this array is going to cover our whole screen. So we are going to say size underscore t. We are going to we need to cast this to size t, of course, because the actual stuff needs to be in integers, not floats. And we are going to also do the same thing for screen height. We're going to multiply this by that, and then you might think that that's enough, but we actually need to multiply this by 4. The reason for that is that we have got like screen width and screen height covering every pixel, and each pixel consists of 4 bytes. So one for the red, one for the green, one for the blue, and one for the alpha. That's why we need to have this multiplied by 4. So now we'll need to change the way that we are writing these pixels. We are not going to, of course, append to an array anymore. Instead, we'll need to write the pixels manually. So let's go ahead and remove that. And we won't have the graphics card or SFML automatically decide it for us. And we're going to change this from texture coordinates to integer coordinates, since now we need to have these as integers so that we can use them as indices in the image texture. And then we'll need to make sure that in case the texture coordinate is negative or is greater than 0, we need to basically make sure it stays within range. For that, we can just use a bitwise and we can add it with our texture size minus 1 less than our texture size basically. But our texture size is actually in float, so in order to apply this operation we'll need to use a float cast to integer basically. So we'll cast our texture size to an integer and perform this operation on less minus 1, and we are going to do it separately for x and y both. So we are going to go here and this. So since our texture size is same on x and y, as it's going to work this way as well. So with that we have got that done, and now we need to actually start drawing and getting the individual textures. For that, we, instead of using a texture here, we need an SFML image. The reason for that is because we are using a custom function for drawing, and we need to access the individual pixels, and we don't need that to live on the graphics card. Instead, we want it to live on the CPU side. For that reason, we are going to replace this with a floor texture with a floor image. So make sure that you change all occurrences of floor texture with floor image, and down here where we are actually rendering the walls, we are going to just use a single render states and pass in our wall texture and not the floor texture here. Back at our floor drawing functionality, we are going to add an image here called image, and this is going to represent the actual image we'll draw. We'll call the image.create method with our screen width and screen height as the actual size of the image, and for the pixels we are going to just pass in our floor pixels array here, and that should initialize the image correctly. And now we can go down here and we are going to create an SF texture, and we are going to go ahead and call this texture, and this texture is going to be loaded from that image because we need to have a texture in order to actually draw the image to the screen. We are going to use image, actually not that, yeah. So we are going to create an SF texture here like this, and then we are going to call this texture, and we are going to say texture.load from image, and we are going to pass it our image which we just created in a custom manner. And we are going to go down here, we are going to create an SS sprite called sprite, and we are going to create it with a reference to the texture. And after we have done that, we can actually not a pointer, a reference, so we don't need to put the and there. And after we have done that, we are going to have our sprite ready, and we can just draw it to the target. So we are going to say target.draw, and we are going to pass it our sprite. Of course that will render our texture, but currently we do not actually have drawn anything. So if I go here, I'm going to just add an initializer list here which should initialize everything to 0. And if I were to just run this right now, I should get a completely black in place of the floor, and there should be no artifacts or anything. So is that works hopefully. Yeah, you can see it works, and we are still getting 50 to 60 fps, and the main reason for that is because the actual calculations we do for floor drawing, they are the most expensive part, not the rendering. So while we could squeeze out a bit more performance with this, it is not possible to like completely get the 1000 fps back without sacrificing floor rendering. But it's not too big of a deal. 50 fps is still pretty good. So we'll go down here, we are going to say floor pixels, and now we're going to start setting it to the appropriate values. Now for the floor pixels, we need to calculate the value basically with x, and then we are going to add to this our y multiplied by the size of our screen width. So the reason we do that is because y represents like the actual row that we are in, so we multiply it with screen width to get that in pixel coordinates, and then we add x to that, which is the actual column. And with this we need to multiply this by 4 because a pixel under our system takes up 4 bytes. So we'll add that here, and then we need to have an offset to this for the actual red, green and blue component. So for the red component, we are going to just add 0, which means we're going to add nothing actually. And now we need to get the actual color at this point in the image, and we can do that quite easily by using the get pixel method on the actual image. So we're going to create an SF color, call it color, set that equal to our floor image dot get pixel, and we are going to pass it our x and y as the actual the coordinates where we want to get that pixel. And we'll need to assign our floor pixels to this correctly, so we'll need to go ahead and set that to color dot r, and then we'll need to set that for like each of those. So we are gonna actually copy this line, so we are going to go here and copy that line, and then I'm going to paste it 4 times, and we are going to change this to color dot alpha. This is going to be 3 2 1 offset. We are going to change that, and for 1 it's going to be green, for 2 blue, and for 3 it's going to be alpha. So with that we should be able to run this and it should work. Well, you can see it does not work, and it actually gives some artifacts. And the main reason that happens is because we are not actually accessing this correctly. We were passing in the x and y of the place we are in, and the screen we need to pass the texture coordinates x and y, so that was a bit of an oversight. So now let's run this, and you can see that we get a floor rendered here correctly, and the frame rate is currently 40, which means we got around a almost a 10 fps boost, which is not a lot really, but there is a way still to optimize the performance further. We could of course change our code to make it more optimized, but we are currently running our code without optimization, so we can just open up the make file, and we are going to try to see how well it performs with optimizations, compiler optimizations enabled. So with the optimizations in place, I'm going to run make. Actually that won't cause anything to happen. We first need to run make clean so that it actually clears all of the old files and updates them. And now if I run make, what you should see is that it should recompile everything, and now we get quite a bit of an FPS boost. It's almost giving 150 FPS, and that's just with the compiler optimizations. So with that we have got our floor rendering optimized, and we have basically done the whole floor rendering thing. And this is pretty much it for this video. And in the next video we are gonna, well, I was thinking, well, the actual ceiling rendering is very similar to floor rendering. You just draw the it inverted, but for in the next video we are actually gonna learn how to draw a kind of sky. So it's going to be a realistic sky in the environment, that when you look around the sky rotates as well to give you a realistic impression. So we are gonna learn that in the next video. Make sure to stay tuned for that. Make sure to like and subscribe as well, and share this video with other people, and bye.